So, good morning. I want to talk to you about, as you can see, a real-world example, how continuous delivery can look like in the real world. So, as you can see, it's all about bricks. Why bricks? It's not only that I'm, for my private interests, also owner of an historical house, but also I think bricks is a good example for producing big amount of bricks, and it's related to building, so I thought maybe a good relation to our talk today. So I want to talk to you, what are we doing and where did we come from, what did we change? But I also have the honor to lead over to the technical afternoon. Maybe some of you are not only waiting for lunch, but only waiting for some more technical things. So I'm starting this a bit by showing how we really do it with Jenkins and some technical details also. So in general, what do we do? You know, Bosch is a huge company, some 100,000 of employees, mostly well known for spark plugs, washing machines, whatever. But there's also some areas where we do software development. One area is software for workshops. And that's what we do. We are developing software for automotive workshops. And you know, it's the tools you connect to the vehicle to read out errors and actual values and get hints how to repair the car, what the issue could be. And so that's a lot of data, huge amount of data, because we try to cover as much as possible different brands and car models. It's also quite a lot of customers. And we have currently two solutions. It's a PC and embedded Linux variant. That means we are talking about a classical desktop application here. We are also working on web applications and mobile solutions for the future, but currently the request is not that big yet, because workshops, you know, they are really fixed on their workshop. They want robust machines to repair, and they often don't have Wi-Fi or bad internet connection. So what they require is still today more such a desktop application. To the left you can see the PC application, which also runs on a normal laptop. And right top, these are the embedded Linux machines. And right bottom, this is the box which connects the car to the PC. So we also provide that hardware. Also, the hardware is developed by Bosch to make it very ruggedized and dedicated for workshops. So I want to show you a quick movie which shows, and these are the bricks we are producing, of course. I want to show you a short movie which is showing you what we are doing, but not how we are doing. So this is not really realistic, but it's a nice movie. So this is the Linux machine, KTS 340, which runs embedded Linux. The application is done with Eclipse technology, Eclipse RCP. And of course it doesn't really look like this. We would like to have it like this, but this is really just a marketing video. I don't know who had the idea to show it like this, but I thought you might find it interesting, because the real technical details are only interesting for workshop owners. So now we are really scanning like a computer tomography the car, and you can see, wow, that part is damaged, you need to exchange it. You can see even inside the car, it's real magic. Then you just click on repair and the machine will do everything itself. No, you have to exchange the part manually. Okay, that's one step left to do manually. But that's really, in a meta level, that is what we are doing. We are scanning the car, showing errors, showing what is the error and giving hints, giving instructions, how to repair, what to exchange. But you know the instructions, it's a lot of text. It would be boring you. Now you get the report, was what repaired, and can continue, go on. Drive as usual, as there was no repair. So that's roughly what we are doing, but in a more entertaining way, as I would show it, how we are doing really. So, why is this application really complex to build? So one part is, you can see we have many developers. We have a huge team distributed all over the world. This is also because we have a lot of car brands and car models. You know, if you want to test the software on a Brazil car brand, then you need someone in Brazil, because we cannot get all the Chinese and Brazil and Russian cars to Germany. So we need distributed teams that produce localized software for the local cars. Also, we have really a big legacy of technologies. We have more than 20 technologies. We have 3 Bosch own created script languages. We have Bosch own tools. We have 15 years of legacy, and we cannot really get rid of that legacy, because we want to offer our customers, as I said, to repair as much cars and brands as possible. So we need all that legacy software, and we cannot re-engineer it because we don't have the cars to test it. You would have to go to private car collectors or museums to get old cars and test everything, and this with thousands of car models, it's not possible. So we have to build and run all this legacy software on all today's platforms. That's the big challenge. Also, we have really big amount of data. It's 3 dual layer DVDs, different data sources, also from different suppliers. We have a number of suppliers also with repair instructions. We get data directly from the car manufacturers and so on. So all in all, it's quite challenging to build this. It's like you would have, of course, a lot of bricks, and now trying to assemble something of it. So how did this look like? When I first came to that department of Bosch, we had that 15 years history, a lot of legacy software which was originally created for Windows 3.11. Then it was ported to the Linux embedded. Cross-compiling was created to get this all running under Linux. And mostly everything was built all the time. But also it was not really one build. There was a database, there was the diagnostic content, which we call it, which are the pieces of software related to the different cars. But there also was the system platform software and so on. So there were a lot of different places to build things. And many people had created their own building place. I'm building the database, I'm building this part. And this had grown, with 15 years of legacy, things are growing slowly. And if you let it growing, you get a quite heterogeneous landscape. And there was a lot of manual interaction, which is quite error prone. A lot of errors could happen. Concretely, this looked like this. You don't need to read anything. It's just that you see the blue boxes are different build systems with different technologies maintained by different people. The orange blocks are manual work, and the orange arrows are manual step to propagate from one to another. So this could take up to 1 week to build the entire product. If someone did one of the manual steps wrong, then it could even take longer. Also, we had a lot of technology mix. Different people brought up different technology. As I said, it was growing over 15 years. Technologies were partially outdated meanwhile. And so of course no one did really have the know-how of the whole build system, of the whole build landscape. At that point of time, we thought, okay, maybe we can automate all this with Jenkins. We discovered Jenkins and saw great continuous integration. But was this the solution to automate this thing? First approach was get this all blue instead of orange, get it all automated, simplify it a bit, but still it would take days to build everything. So maybe you know this idiom, if you have an automated mess and you automate it, if you have a mess and you automate it, you have an automated mess. So we would have come to a factory, but a factory of 19th century. This is not what we wanted. So we had to go back and think again what to do. What are we really producing? It's a lot of different artifacts, big variety of artifacts. So we decided to really also split up our software in those 10,000s of small artifacts. Now here we have the main thing, that's the content, the diagnostic content, so-called. It's not content, it's 10,000s of pieces of software. And we really split up our software in these pieces, creating builds for each of them. Then we have the integration builds, which put all this together. Of course, we have database and platform builds. And we have the integration builds, which put all this together. Now, we have reached the goal to deliver the software to our testers within an hour or even within some minutes, updating only single artifacts on their PCs. So meanwhile, we are, for the PC variant, we can really update within a few minutes, what took days or up to weeks before. And for the embedded Linux devices, we are producing such SD cards. And there is a card station, which you can see a bit in this picture. And you can directly take out such a card, put it in the embedded device, and test the software within, in best case, one or half an hour. So that's one point, interesting point to think about. What are really the artifacts you are producing? Did you ever think about really splitting up your software in small artifacts? So what else did we change? Of course, we tried to get rid of all those legacy tools, which were partially outdated, even unstable. For this huge amount of data, you are always at some limits of the tools. So now we have started to unify this to get it all over the entire build landscape, controlled with Jenkins, of course, so that you also have the transparency. Before, you had some build systems started by batch files, started by homebrewn HTML pages, started by final builder. You didn't have the overview over everything. So we aligned everything to Jenkins and ported a lot of builds to Gradle, stored the intermediate results in Artifactory, those 10,000s of artifacts. And of course, for the Linux side, we also try to unify everything a bit, which are in these cases shell scripts producing the builds, which are also modified to get them running into Jenkins and, let's say, compatible to Jenkins workspace. So this is still ongoing. There are some old technologies left. You can't do this at once, but we are on a good way. So these are the bricks we are building and how we try to get them more lightweight. Also, on the other side, not only on the build side, we were also related to the development and tooling side, because we have quite special situations, what and how it is developed. People are focused on the cars and on the expertise of repairing cars. A lot of them are not really software developers. We have tools where they can develop software by creating visual workflows and by filling out tables of data. And this will be generated into a piece of software. So they need quite custom tools. So it's not only that we improved and automated the build chain, but we also aligned all the developer side of the tooling. So we developed tools that synchronize their local installations with Artifactory every few minutes, within a few minutes. Before, they had to do runs of many hours to update their environment with all the changes of all people worldwide. Now it's synchronized worldwide within a few minutes. Imagine the developer in India is developing something for a car in Brazil, and the guy in Brazil sitting in the rainforest with a 56K modem, he needs to update and test this on his car. So this was quite difficult with the old landscape. It took days and sometimes even weeks until they really were synchronized and had everything running. Also, people often want to create new artifacts for new car models, new ECUs, the electronic control units in the cars. And so this should also be one click to create such new projects. They should not manually create things at many places, but just do it with one click. Also, if they say for the release before we need a hotfix, but the artifact was already changed, for these people, as they are not software developers, it's difficult to explain them how to branch, how to set up the environment for branching and everything. So that's also automated. They can create a branch with one click. The release manager can say, I want to produce a release which is taking this branch. So also on developer and release management side, we did a lot of automation for ease of use for those people. Also, you can imagine in brick production, there is really children work, people carrying around bricks in India without load distribution. Of course, load distribution is an important part for our software with these big amounts of data and builds and this many people working on it. We usually have, for one Jenkins master, 2 Windows and 2 Linux machines, because we need to cross-compile things. On the Linux machines, build these SD card images, and on Windows we need to create setups. And we can take one of these machines offline, maintain it, update it, without disturbing the build chain. So from the timeline point of view, what we had before in 2011 is that when developers developed a task, and until it was built, could take up to 1 week, until it was tested, even more, and then developer got a feedback and he had to think back, what was I doing 1 week ago? So you can imagine what this means. Also, this build was only one release candidate. Today, we have a feedback within minutes. We have the testers synchronized within minutes. Even if they are in another part of the world, they can test on the car, give a feedback. So this is now all, the whole development cycle is really speed up. Note that this is days and this is minutes. And also of these 10,000s of builds, any combination, like the green circles show, any combination of them can be a release. And you can always say, oh, of that one artifact, let's take one version earlier, but the rest we can take the current ones. So at any time you can have a release candidate without waiting for any build. And then packaging it to the DVDs for the customer, that's just thing of some hours at most and not of days. So I hope this looks like a bit more continuous delivery than what we had before. But still, you know, in real life you never have really school box solutions. So there's still a lot open to do for us. Not everything what I've shown you is really live now. So we are going live in the next weeks with the remaining parts. There are still some old systems to unify, but also we need to get back to our ingredients of the bricks and extend continuous inspection with SonarCube. We are doing that currently only on a few projects, and we want to do it for the entire project. Also, regarding test automation, we have some test automation, but you can imagine we need to simulate the cars. We always need the hardware connected, so it's not that you just take up a virtual machine and do the testing. It's a lot more than that. We have some test automation with car simulations and our box connected to the car simulation, but this needs to be extended and needs to be connected to the continuous delivery pipeline. So currently the continuous delivery pipeline is without that testing automation. So there is still a lot of work to do, but that's how it is in real life. Now I want to lead over to some more technical information. How did we do this? I think that's also an interesting part for you. How to manage these challenges with 10,000s of builds, with such many projects and users, and the special requirements from the users which are not really developers, and also is Jenkins scalable and stable enough for such a challenge? So let's get a bit more technical now. As you can see, we made a nice brick architecture to manage all these challenges, and I want to show you how it works. So first challenge is how to manage 10,000s of builds in Jenkins. Maybe some of you already know how this can be maintained. Of course, the templates plugin is a good approach for that. And I'm going to show you how that roughly works. So let's look inside our build systems. We now have here the main part, the trunk of our systems. Of course, this is just a playground environment. If I'm going inside these SD systems, which are the 10,000 builds, takes a moment to load. And then we can see that all these 10,000s of builds are created from one template. If I'm looking inside, so it's still loading, it will take some time. If you look inside one of these many builds, you can see it looks like a quite normal Jenkins build. But if you go to configure this build, then you will see only one field, which is the ID of the system. That's all, nothing more to configure. So for those of you who don't know the template plugin, you can see this job is created from a template. If you configure this template, you can just see how it works. Basically, what it does a Groovy or a Jelly-based template transformation. And now here you can place your Groovy code where you just create a Jenkins config XML programmatically. Say, for example, is this job branched? Then I'm using a different description. This job is branched from that and that, and so on. So of course you need some coding for that, but all in all it's quite simple. If you get a bit familiar with Groovy and with the Jenkins config XML, you can create whatever you want here. And if you apply this the changes will be applied to all of your builds. In our case, the 10,000s of builds, even quite fast. So you can maintain your builds all at once. That's a great thing. Still, this templates plugin is in the very beginning. There would be a long wish list. What else we could do? Maybe for a lot of use cases, you would not need such extensive scripting. It would be a nice low entry level to have the templates plugin also with the UI creation possibility and such. But it's a very promising thing. Keep an eye on it. Next example is, how do you organize? You can see if you have such many brick burners working in your brick yard, how do you organize this without that all the maintenance gets stuck on you, that you personally have to give all the access rights, create new projects, whatever. But delegate this a bit to the teams, to the project managers, to the architects. So if we look inside our PC platform product, which is called tronic 2.0, there you see we have different branches currently running. This is the live system, by the way. For each branch we have a folder. This is done with the Folders Plus plugin. If I look inside the trunk, you have many build jobs which are doing different things, building different parts of the software. If I now look into the configuration, which is the configuration of the folder, not of a build project, but of the folder, then you can, for example, say I have environment variables, for example, the branch name in Subversion, the people who are notified when a build breaks, a major and minor version, a share where it's copied to some people, and so on. All these environment variables are defined then for all your build projects which are under this folder and subfolders and wherever. You can also restrict which kind of children can be created in that folder. This is important when you say your project managers or your software architects are allowed to create builds on their own. Then maybe you want to restrict that they, for example, don't create a freestyle project and have the full control of shutting down your Jenkins or creating or deleting jobs by using, for example, Groovy System Script. No, you want that they exactly create what is related to their project. So you can restrict all this. And again here, the template plugin comes in account also. So maybe you give them templates and restrict what they can create. Now the interesting thing about that is when you create a new branch and you want the build systems for that branch in place, you can just copy the entire folder. With the Folder Plus plugin, that means you copy the folder, you have all your build projects already in place, and you just, if you made a clever architecture, you just modify the attributes of the folder, modifying that environment variables that I just shown you. Then your branch is already done. Also, with the role-based access plugin, you can say, in combination with the folders plugin, give certain access rights to certain people. For example, you have developers, project leaders. Now, if you look into the role accessed, assigned to the project leaders, so here are some team heads, group from Active Directory, LDAP, and they are assigned the project manager role. Now you see that those people can also manage the groups. So they can themselves add new group members, but only for this folder of their project. So we have delegated all the user management to the project manager of this project. And as we have dozens of projects, you can imagine if all that would have to be done by the build team, it's not fun. You are delegating this to the projects. Same you can say, are they allowed to see all the jobs? Are they allowed to wipe out the workspace? Are they allowed to update the run? What means, for example, adding a description to the run or saying keep this run forever, such things. So with the combination of folders and role-based access, you can quite well manage a lot of projects and delegate work to the projects. So the third example or the third challenge is, as I said, users want to create new projects, but they are not really technical related. They are focused on their expertise of car repairing. So what we do is some meta automation. You see, they always have ideas of new brick artifacts, new funny artifacts, and we don't want to stand them at our desk all the day. For my funny artifact, now I need a new build. So we did some meta automation. Let Jenkins create build projects automatically. And something similar is let also Jenkins monitor itself. So how does this work? For example, here we have create new SD systems. You remember this is the artifact collection with the 10,000s of artifacts. Now I'm creating a new one. This, as you have seen, gets an ID, gets a name. Let's say it's an airbag 123 of a BMW car. So we start the build. Within a minute, this build is copying a template in Subversion, so that already the source code frame is in place. It's a template which is replaced by the parameters I have entered, so that they can immediately check it out and work on it. But also, this is creating the related build systems. While this runs, let me show you the other interesting possibility. Here we have one of these SD systems. We have run a few builds. Now people say, that build number 1 went into the release where I urgently need a hotfix, but I don't want the modifications of build number 3. No problem, go into the build number 1 and say, create a branch based on this build. This is a little plugin we developed. Now enter the name of the branch. Let me call it Jenkins Continuous Delivery Day 2014. Now we are forwarded to a build which says create a branch of an existing system. Meanwhile, let's get back to the other one. It has now finished. And if I look inside this build, I can see it has created that new system 9978. Here I can check it out from SVN. The URL is listed here. And here I can see the job, the build project. So I'm inside the build project. I can start the first build, which makes no sense because it's an empty template. This is why the build is not triggered yet. And I can check it out from SVN, modify it, fill it with first content. And of course, by creation of this build, it will also fill Artifactory and the synchronization for all the developers and testers worldwide. Once you have filled it with content and run the first build, they will distribute it worldwide to everybody, because then it's created in Artifactory. Same thing for the branch. Branch was created now. Let's have a look at our main folder structure. Now we should have a folder here which is created Jenkins Continuous Delivery Day. And inside this folder there is one build project. Already the build is running. And this is the branched build for the branched SVN branch. And of course, if you create more bug fixes, more hot fixes with the same branch name, branch Jenkins CDD 2014, all the build projects will end up here. By the way, this is a filtered view because of course the branch will contain all the other things also, but and it has a folder structure below it. If I open the build project, you can see this is not only the branch, but there's a folder SD systems in between. But not to confuse the user, we are often filtering the Jenkins views to show what the user is interested in. In this case, it's only a handful of builds. He doesn't want to see 5 folders and look in which folder is a build or not. He wants to see only the branched builds. Where compared to the trunk view, there we show him all the folders, because in every one of the folders there are hundreds or 10,000s of builds. Here it makes no sense to show all the build projects in one view, but better filter your views, customized to the needs of your users. So last thing regarding this meta automation is let Jenkins monitor itself. Why not just use Jenkins Groovy system script? There you have the full access to all the Jenkins API, and you can collect a lot of information, or let Jenkins monitor itself give you a warning when something gets critical. Just one hint, don't try this on your productive system. By one mistaken line of Groovy code, you can, for example, rename or delete your entire Jenkins project. Don't ask if this happened to us. Now, for example, say you monitor the disk space of something. On your Linux machine, execute a shell script, take a Groovy log parser and see what it says, and if disk space is low, send an email to everybody that is concerned. Trigger your backups from Jenkins build projects. Check which builds have certain conditions which you consider as out of order. Or collect informations which jobs are copying artifacts from which other jobs. Collect information which jobs are using which plugins, for example. Yeah? Just create an HTML page which shows you which build projects are copying from which artifacts, which build number, and how big it is. Do a report which plugin is used in, which plugin is used in which build project. And so on, just a set of HTML reports. It's all up to you. Just be creative. Think about what else you can do with Jenkins than just building your software. What else? An interesting thing is going to the limits. As I said, we have 10,000s of build projects. We have 100,000s of files. Under Windows, always exceeding the size limit of the path length and such things. So at many places we are really going to the limits. Does this work with Jenkins? All in all, yes, it works. We even have, before we are going live with this system now, we have 3 playground environments in parallel, so we even have 3 times the build project and data amount that we will have in real operation. It works, but I can recommend you, don't be feared of patching your Jenkins. Don't be feared of creating new plugin, patching a plugin to your needs, because when you go to the limits, this will be needed. For example, we had bugs where we had the problem, if you want to show all of this 10,000 projects, it can get stuck forever or take forever. So we made a patch to remove some recursive API requests which were not needed in this case or such things. So you can make small bug fixes your own if you dive a bit into the source code. That's the big advantage of open source projects. Take this advantage and do it. Of course, you need to dig into the source code a bit and build up some in-house know-how in your company. Unfortunately, our know-how is partially outside of Bosch. We have external employees also helping with this. Better would be to have really in-house know-how, to have fixed employees doing this. Even if you do this, patch some plugins and the Jenkins release, if you do it intensively and if you continue in your free time, you can get one of the top core committers, which is Daniel at the place number 4 in GitHub. So this can even extend to a small hobby. In parallel, or if you don't want to dive in so deep, you can get professional support. We have a Jenkins Enterprise license which includes support. Also, a lot of our problems are solved by Jenkins Enterprise support. You see, this is the team from CloudBees. Always ready to get hands-on and deliver your bricks. Thank you, Al. So this also helps. Best is combination of both. Yeah, so much for the Jenkins and technical side. As a conclusion, I would say continuous delivery really allows instant results. Even you have a challenging size and complexity, you can think about creative solutions, splitting up in really small parts. Then you will really end up in instant results, although your environment is pretty huge. Also, Jenkins is really ready for challenging projects, although you may need some customization, some bug fixing, but it is possible. Enterprise plugins can be helpful, as I have shown. Professional support can be helpful. Still, you should build up your own know-how to be ready to fix something on your own also, because that makes you more flexible. And if you do all this, then you can take your bricks and build something really great out of them. For example, this is the world's largest bridge made of single bricks mostly, and it's made of 26 million of bricks. That's even more than we have in our project. So go on, build some great things with continuous delivery. That's all I have for today. Thanks for Daniel, who did all this implementation stuff mainly. And don't forget, if you don't want to end up your software bricks like this, do some continuous delivery. Thank you. Thanks. I think we have 5 minutes for questions still left, if you have some questions. Yeah? We are running 2 instances of Jenkins. One is more for the system software parts, the software projects for the system software, and one is for that what we call content, which is the 10,000 pieces of software. So it's 2 Jenkins instances, and one idea is also to keep the 10,000 artifact instance quite clean. So this has really few plugins, while the other one has, don't know, currently 40 plugins or so, even more. Because it needs more functionality for these system software platform projects.
So for running 10,000 jobs more or less continuously, what would be your infrastructure and Java settings for this Jenkins instance? Or maybe it is too technical.
Yeah,
from my experience, the instance should be huge, at least for my load.
You mean the machine where
Machine
when
and
it's
Java
running?
settings.
Yeah. We have in-house IT service, and they host virtual machines for us on a VMware cluster, and it runs quite well. We are just ordering the biggest machines they offer, and that's all. But I have to limit this. We are not running the 10,000 builds all the time. I mean, that's also the advantage that we are taking now. Before, we were building everything. This took hours and days and weeks. And today, we are only building the artifacts that are really changing. So these are maybe only 100 a day or 200 a day.
So speaking about artifacts, I understand you selected artifact again Gradle to mess all those multiple artifacts which probably depend on each other.
Yeah.
Do you follow some dependencies, maybe some transitive dependencies?
Yeah.
So how you manage those 10,000 things which are interconnected
So
between each other?
question is how we manage the dependencies running Gradle and Artifactory together. Yeah, that's also one point where we still have work left. So a lot of dependencies are not yet modeled in our environment. We are using dependency management from Gradle in the way that we create, when we're making a release, we are creating a huge XML file which models all the dependencies, which is like kind of a tag done on Artifactory, and from this we are then building the release. This is kind of our dependency file, but a lot of dependencies are not yet modeled. This is something that was still missing in the old world, and it's also not yet implemented in the new build landscape. Yeah. Any other questions? Yeah.
Actually, two questions. One is about the three plugins you mentioned. You mentioned the template plugin,
Yes.
some folder plus plugin, and role-based access plugin. And you
Yes.
also mentioned that you use the enterprise version.
Yeah.
Are those three plugins free plugins or?
Regarding the plugins, the question is regarding the plugins we use. So of the folder plugin, there's also a free version, and the Jenkins Enterprise contains the folder plus plugin, which has more possibilities. So what I've shown you to define the environment variables on folder level, I think that's only in the folders plus plugin and not in the free one.
And the second question is about actually storage performance. So you have a very large installation, and our experiences, if you have a lot of builds, so we have only a few thousand, but still, depending on how long you store your builds, so how long your build history, how long you keep, and how many builds you keep, that you may enter some issues when it's about cleaning up old builds. So when a new build runs and build history needs to be cleaned up. So how do you optimize this when you have so many builds?
So question is about how to maintain many builds and how long to keep the build results. In our case, it depends. We have these 10,000s of builds. They are really small. Results are uploaded to Artifactory quite fast, so there it's no problem. We just keep all the artifacts in Artifactory. But for the product build, for the entire product, it's 5 or 10 or more gigabytes. Of course, if you keep a lot of builds of that, your disk will run full faster than you can clean it up. Also, cleaning up takes some time. So here we have chosen also to deliver the really huge builds to network shares. And from these network shares, people that do the final testing, that really install the entire software, like testing it from a DVD, they need the entire product, of course. You cannot update single artifacts there. And for them, we offer a kind of DVD image on a network share. And this share is then cleaned from time to time. but we don't keep these build results in Jenkins, only one. Another question?
Touched the topic of plugins, free plugins and enterprise plugins. Since there is this arrangement with older plugins availability in free edition and enterprise edition, is it possible to have, it's a question about this, is it possible to have similar arrangement with templates? Maybe in the future.
Sorry, I wasn't paying attention until you mentioned cloud-based.
The question is there if there will be a free templates plugin also.
Well, we don't currently have plans, but we don't currently have any plans.
So currently no plans? Yeah. In case you didn't hear.
One more question. Then we're
One more.
Since you got a very big environment, my question now would be, how many Jenkins administrators do you have in-house, or is all dedicated to CloudBees?
No, we are running everything in-house. CloudBees is just providing the Jenkins Enterprise license and on-demand support with support tickets and delivering maybe patched plugins or new releases. So CloudBees is not involved in-house. And in-house we are a build team of 3 internal and 3 external employees, which are working on different fields, running the current things and in parallel developing new things and so on. So the operation is mostly stuck on 2 or 3 people.
Thank you, Harold. Thanks very much.
Thanks for listening.